Hello everyone, this video has been brought to you by Unacademy. My name is Mohit Gupta and in this video I will be talking about the second part of Bresenham's line drawing algorithm. If you haven't watched the first part, I request you to please watch the first video on this topic and then continue with this one. For those of you who have watched the first part already, let us see what happens next. We saw that for a line to be drawn from some point to some other point having coordinates xk, yk, starting coordinates, and some intermediate point y, and yk plus 1, we have to decide between choosing the pixels yk and yk plus 1. At every increment of the x coordinate. And how we did that? We mentioned two conditions, d upper and d lower, and we found out one decision parameter, that is pk equals delta x times d lower minus d upper. That was the decision parameter that we found out, and we decided that if pk is positive, then we take the point as the upper point, upper pixel, and if pk is negative, then we choose the lower pixel. Now let us examine one thing, that when are we to use this decision parameter? All the coordinates on the x-axis are moving in unit distances. Therefore, we can have all calculations in integers. The fact that we are having all calculations in integers, this is what makes this algorithm better than the floating point algorithms like DDA, etc. So now let us see what a k plus 1th step will look like for a decision parameter. So we will have pk plus 1 equals 2 times delta y x k plus 1 minus 2 times delta x y k plus 1 plus b. Now we see that this term x of k plus 1 is same as x of k plus 1 because we are moving in unit distances. So we subtract pk plus 1 minus pk, and we get 2 times delta y xk plus 1 minus xk minus 2 times delta x yk plus 1 minus yk. Now due to this condition, this equation gets reduced to pk plus 1 equals pk plus 2 times delta y minus 2 delta x times yk plus 1 minus yk. So this is what this equation gets reduced to, and we see that yk plus 1 minus yk can be either 0 or 1 depending upon which pixel is selected. That is the decision parameter sign of the decision parameter p of k. So the first decision parameter p naught will be calculated as p naught equals to 2 delta y minus delta x. Now let us state everything that we have learned so far formally in the form of an algorithm. This algorithm in the first step takes input 2 points, their coordinates x0, y0 and x1, y1, where y1 should be greater than equals to y0 and x1 should be greater than x0 to make the slope less than 1. Secondly, we plot the point x0, y0. After that, we calculate some terms like change in x, change in y, 2 times change in x, 2 times change in y, and all the terms that we require in the formulas that we discussed before, and then we calculate first decision parameter, that is 2 times delta y minus delta x. In the next step, at each xk, remember this diagram, x1, x2, x3, at each of these points we have to calculate the y coordinates. So in the fourth step, we see that we calculate the pk. If pk is greater than 0, then we plot the point xk plus 1, yk plus 1, and simultaneously the pk plus 1 becomes pk plus 2 times delta y minus 2 times delta x. Also, if pk is less than 0, then we plot xk plus 1, yk, and simultaneously the pk plus 1 becomes pk plus 2 delta y. So that is what we do in step 4, and in the final step, step 5, what we do is repeat step 4 for delta x minus 1 times. So how does it come, delta x minus 1? We have to calculate at every x index starting from the first. So that is the change minus the first, that is p naught. So delta x minus 1 times, we have to repeat the step 4, and this concludes the algorithm for line drawing that we just discussed before. So if you want to watch more videos in the same series, subscribe to this channel, youtube.com/unacademy. The more videos that are about to come are the example on Bresenham's line algorithm, and you can also watch the first part of this algorithm. If you have any doubts or queries, you can ask me on Twitter. My Twitter handle is @hi_Mohit Gupta, or you can directly tweet to the Unacademy. You can also leave a comment in the comment section of this video to suggest us topics on which you want to see educational videos. Thank you. Thanks for watching.